All right. Okay. I think we can start. I'd like to thank everybody who joined us today, and welcome to today's CNCF webinar, Building a Kubernetes-Powered Central Modules Repository. And my name is Baruch. I'm CNCF Ambassador and Head of Developer Advocacy with JFrog, and I will be moderating today's webinar. And today with me, our presenter and my colleague from JFrog, Rimas. Hi, Rimas. You will introduce yourself better. Senior solution developer at JFrog. Just a couple of housekeeping items. As it is a webinar, you're all on mute, but we do want your feedback. There is a Q&A button in the bottom of your screen, so feel free to start asking questions, and we will take as much as possible towards the end as time allows. With that, Rimas.
Yes, hi. So Baruch mentioned my name is Rimas. Don't worry about pronouncing my last name. I work as senior solution developer at JFrog, a really big supporter and fan of open source. I think it's a good future still ahead of that. A while ago, co-founded Helm, wrote Core's Essentials book, and from a sweet side, I love coffee, green tea, halva, and cheesecake. So at JFrog, we really love Golang and Kubernetes. And we have been using Golang since 2015. And when Go models were announced, we got excited. But at the same time, soon we realized that using Go models doesn't really guarantee us to have reproducible builds. So whatever you fetch from GitHub could be a different version every time you get it. Because people sometimes not version properly. But we keep the same version, but update the code. So you cannot have reproducible. So that's our was motivation to build Go Center for Golang community. And of course, why not use Kubernetes as a platform? As it takes care a lot of platform level requirements, and at the same time ensures that we design our application in a cloud native way. So basically, we are building better apps at the end. We had a huge mountain to climb, which basically to build a Go Center repository. It wasn't easy, lots of mistakes and made lessons learned. Of course, we started from 12-factor stateless applications because we don't want to store state in local file system, because instead of store in databases, message trees, and etc. And this, which of course makes it a very cloud native friendly application, because, for example, your application restarts, has no state, just can resume a job. And doing, of course, that you have to handle graceful shutdowns. For example, if your application is processing something, it should stop and then send it back a queue before the pods are gone. So the next pod can resume and continue processing data. So let's talk what lessons we have learned and what best practices we implemented. First, we picked Google Cloud and of course, Google Cloud Kubernetes engine. Why? Because Google offers mature Kubernetes offering. Everybody knows Kubernetes came from Google, so we can trust them. We have a good choice of managed services. In our case, we need Cloud SQL, PubSub, so we can concentrate on our job. So, and even building better apps and DevOps teams just could focus on delivering value, not reinventing the wheel, fixing, patching, Postgres, RabbitMQ, and so on, etc. Google Cloud, of course, offers a good choice of troubleshooting tools like Stackdriver, BigQuery. And we love using regional GKE clusters, especially for staging and production, because your nodes get spread between different regions. You do your masters, GKE masters are HA as well, so we can do an upgrade of your Kubernetes cluster. At the same time, you can roll your applications as well. So basically no time. Of course, there are some glitches time to time in Google as well, but generally it's good. So currently we're running totally 5 Kubernetes clusters. And each of these environments has a complete installation of Go Center running. We have CI, dev, test, staging environments, every different projects, totally separation from each other. And staging production, they're very, very similar to each other. So, because how else you can test before rolling to production? This is how our clusters look like. So you see on the bottom left, we use Google Cloud, so that's basically our backend, SQL, PubSub. Afterwards, we use Artifactory as our SaaS Artifactory to store Go models. So Go Center is basically a client of JFrog as well. And Go Center runs in Kubernetes cluster. We have many different microservices. Most of services, we try to use single container per pod for best practices. Of course, there are some init containers which start first do initialization afterwards the main pod starts. But for UI microservices, we implemented Sidecar because we need some engines to run in front of UI, so we can intercept all traffic, apply some security rules, rewrites, caching, because we are using engines ingress, which has limits with caching. So having a sidecar for engines as an engine container solve that problem. And we are big on pipelines and promotions. Everything starts, in our case, from a future branch, where developers release a code. We can test it in the real cluster. It's not like a story. It works on my machine. It should work in a cloud. Everybody can access. Be happy. We merge to master a branch. Afterwards, CI system kicks in, builds Docker image and Helm chart, because we version everything, and versioning Docker image, we have to use that in Helm chart, so Helm charts versions as well. And we start promoting everything one by one afterwards. When CI passes, it deploys to dev and test clusters. So we can do again different tests on 2 different environments. When we're happy with those environments and tests, we deploy to staging. Staging is very similar to production, so we can apply different tests, like thousands of clients accessing at the same time, house testing, and so on, etc. When we're happy with the staging, of course, that goes to production. So at the end, we have 6 different environments. It looks a lot, but that still allows to do maybe 2-3 times if you want to per day, different releases. Because like CI server tests, they are quick, half an hour, and I think it's tested. Our manual tests we run afterwards on test, staging, even on production. We're not too long as well. So we try implementing everything with the best practice, like Tiller's Helm, secrets, namespaces, persistence, props. Okay, so let's go one by one. So Tiller's Helm. At JFrog, we use Tiller's Helm v2. If somebody who's familiar with Helm, we know we have to learn Tiller in a cluster, which, of course, nobody likes that because that's security breach, because you have to apply cluster-wide role if you wanted to deploy every to different namespaces, or you have run multiple tillers per namespace, so that's a maintenance burden. Of course, we have to keep in mind even running different custom controllers and operators. It's the same story with them as well. So cluster-wide, namespace-wide, RBAC rules. So we use tiller as Helm by V2, which basically runs Helm client and tiller together off a cluster in the same container, which does deployments. So all our Helm charts are versioned. Wherever it's a new Docker image, we do a new Helm chart release. Even a Helm chart changes, which needs to be deployed, we do a Helm chart version as well, new chart. So that easy us allows to roll back with Helm rollback to a previous version. We have separate values files per environment. As we have 6 different environments, we have 6 different override values file per environment, which all get stored in the same Helm chart. Different URLs, different IP connection databases, and Elasticsearch, and etc. So when you're deploying the same Helm chart or in different environments, you always have the same values file. So CI knows which one value files to use per environment, because it's not good to build even a Docker image per environment. We build once, and afterwards we just we do promote, and promote per environment. Even our secrets are Helm charts, because that allows easier to upgrade them. And of course, secrets are external secret. We call that as external secrets to our applications. So in CI/CD pipelines, you don't have to worry about fetching secrets, we deploy them again, because they are referenced as external secrets, so we don't have to worry in CI systems. Every application has a namespace. So because the application like Elasticsearch runs a separate namespace, which basically single purpose. Monitoring has a namespace. Application separate namespace. So basically one thing does well and solves the problem. So for good practices, we have to use readiness props, readiness and liveness props. So if something happens, pod gets restarted. Maybe your database is not available. It gets restarted. As well as I mentioned, we're using GKE regional disks as well for cloud storage. So that allows for more HA, which need a state to be more HA. If pod get killed and get restarted in different zone, using the regional disks, that allow to work, continue to work. If that one zone is gone, so that allows you to be really HA. This is exactly we're using for Prometheus, for Elasticsearch, because that's all the state we have. We don't store anything else except the external database or PubSub queues. So resource limits. As we deploy with using Helm, our chart sets limits on all services we deploy. Again, it's the best practices. And we leverage some complex calculations in Helm to make sure we don't overpopulate our nodes. Every deployment also sets resource limits on the services that is deployed. This is quite useful for auto-scaling, but it's also guard against pods using too much resources, which could impact our overpods running on the same node. For example, if your node is used almost nearly 100% of CPU, basically it loses all connections to database, to network, to everything. So basically it becomes useless. So you always have to set not only request the minimum request you need, but a limit, the max you want to give you application that of course needs proper calculations to be done, proper testings with load testing and etc. So we know how your application behaves and how much you give it. As well, for HA, you need to use node and pod affinity. Especially if pod affinity is good. Using pod affinity allows, if your application has microservice, has five replicas to run. If you don't use pod affinity, it could land on the same node, 5 of them, because if that node has resources. If that node for some reason gets killed, is getting an upgrade of GKE or something else, basically your application goes away and will take, could be a couple minutes, a minute, half a minute to be redeployed on different nodes. So using pod affinity allows to spread them. So only one pod from the same replica set will be deployed on the same node. They will be all spread around. Even that one node is gone, if your application is properly done and developed, it will not harm at all. So scaling on many levels it can scale. So first, provision nodes when needed. We use node autoscalers to start new nodes if existing nodes are saturated, busy, or have resources to run. And of course, that's based on those resource limits I just was talking about. So next, compute. Compute-based autoscalers, we start new pods if a CPU usage of certain pod is really high, like horizontal pod autoscaling. So if CPU, for example, usually it's recommended to set 50% of CPU RAM. If it goes more, deploy a new replica. So you not overkill your application at that time when the next pod gets deployed. If you set 80, 90%, it could have a big hit. And when new pod is deployed, basically that pod could become too busy to accept more traffic. Also, so for compute, we have a couple services using RAM and CPU. Most of the services we use PubSub. Queues we check with HPA like custom metrics. And if queue is bigger, we scale more pods. So basically we're using native HPA compute and CPU autoscaling and custom autoscaler using with PubSub. And of course, so that's a messaging. And when peak is gone, the CPU is less used, PubSub is clean, so we scale everything down. Because why you should pay for things you don't really need to be paid for? So it should be scaled from 5 nodes, 5 pods to whatever is allowed to set in your autoscaling groups of pods and nodes. So for example, so this is like how dashboard looks like, and we see whose peaks. So that means like CPU utilization was high. So looking to this, we're gonna do some little maths. So for example, our node can accept 5 pods. So we have 15 pods running. We have 3 nodes. Autoscaler kicks in, tries to deploy 25 pods. If we don't have them available, node autoscaler scale extra 2 nodes. Then those extra 10 pods will get deployed. When everything cools down, everything will be back to 15 pods, the minimum we set, and 3 Kubernetes nodes. Node pools. Node pools, it's very powerful stuff, and it's And in our case, we have a few different types of node pools, like for persistence, for like default node pool we're using to run a couple microservices for Go Center views, which shouldn't be restarted because they process data a lot, and they're restarting it could take a while to pick it up again. We have a preemptible node pools. Most of our microservices are running. If somebody's not familiar, preemptible node pools is basically offering from Google. You pay only 5% of a real price. We live only 24 hours. And they really good for peak traffic. But we run about 80% of our microservices on preemptible node pools and VMs. But we set 6, at least in production set 6 pods per each microservice. So we spread around between 6 different nodes. If one node gets killed, nothing much happens. We're not losing much because the most important microservices, like processor, they're running on persistent proper VM, and the rest is on PVMs. And imagine having 6 PVMs, and you're paying only for 2 of them. Even it allows us to have more powerful VMs to be used. We leveraging, yes, so as I mentioned, PVMs, we live on 24 hours, and close to 24 hours, the whole node pool could be killed at once. So we don't want that to happen. So we use GKE PVM killer made by SFT guys. So that small controller, again controller, but it has, which runs, doesn't need any cluster-wide RBAC access, which runs in Kubernetes cluster, labels all PVMs, annotates all PVMs, and after 12 hours, starts itself killing them one by one, but of course not at the same time. So we, in this case, we have a much better control when PVMs go away and come back. So far, so good. We're running that way more than about 7 months. Big, huge savings using PVMs on one side, and we have more resources. We can accept more traffic. So this is how node pools look. So default node pool, we're running most important things for stateless microservices, but it should be killed every 12 hours. We have elastic node pools for master and data, because we use Elastic to speed up our search in UI, and the PVM pool. And as you see, all the regional ones, so we have 3 regions, every region, 3 zones per region. Every usually runs 2, 3, 5 nodes per zone. Next, we try to keep a close eye on clusters and containers clusters. Basically, we leverage a lot Stackdriver. So with Stackdriver, we have uptime checks, which these peaks, you can see these spikes, because uptime checks are done from all different regions, Google regions, and time by time regions, we have some spikes, very latency, and we get notified by Slack. Something happened, we check. It's usually some network latency at Google side, but it's good to be notified about that. As well, we leverage a lot Stackdriver logging. So why we should use something else if there is a login side already? Part of a managed service provider by Google. So that's frees up from running Kibana. We have our Kibana for testing purposes, but not using much yet. But this is a really cool one. You can check logs, you can export logs to BigQuery, you SQL queries against that. And of course, we have Prometheus with Grafana, because we like different dashboards. So we can check different things. We can apply different alert rules on Prometheus side, on Grafana, in Grafana as well. So house engineering. We use house engineering a lot, basically. Killing nodes, killing pods, checking how it behaves. But good thing as well, we have house engineering by default, because using PVMs, sorry, house engineering, because pods get killed and nodes get killed every day. So basically in a real time, even in production, we have a real-time house engineering. But we, of course, do extra things. We test in advance. We pretest in dev and test clusters. Load testing. We do different load testings. Jamming our API, jamming UI, the only different 1,000 users, different Go models. Maybe checking how to behave. Maybe if you roll out a new version, maybe it needs more CPU and RAM, maybe more resources. So everything has to be very, very well tested on that side. Because if you don't pretest your even infrastructure plus applications, it could end up very, very badly afterwards. And of course, we wanted to keep in touch with our nodes, with everything, and so on. We use a small kubeSlack application, which checks for pod got killed, pod got restarted. And when we deploy the new version, we notify as well in Slack, because we have a support, Go Center support Slack channel. So that get notified. The new version got released. It's getting released. So support guys, they won't freak out. And it's finished. So release is finished. Because when new version release, of course, you will see the extra messages. Pods start to be killed and recovered. So at the end, this is how our Go Center looks. Basically, we use Go Release ourselves as well. It uses Go Center as well, and the interface is nice of a Go Center. So maybe we can now come to questions part.
Rimas, thank you very much for this presentation. I want to remind everybody that now it will be a very good time to ask questions. The way you do it is via the Q&A panel you have on your webinar display. And while you are typing your questions in, I want to remind you that KubeCon plus Cloud Native North America coming upon us relatively soon. It's the flagship CNCF event, and this year it's in San Diego, which is the best location that you can find for conferences in November, because it's nice and shiny. And obviously do not miss. For many years KubeCon is sold out, so now will be a good time to grab your tickets before it's sold out. So with that, let's see if we have any questions. So here is one question. Do we use any open source tools for chaos engineering and load testing, or do we use something that we build in-house?
So we use BlazeMeter a lot, and of course Bash stuff runs as well. So loads of in-house stuff done with Bash. So both.
Yeah,
we
so
use a lot. We use a lot. If we can, we start trying to use a lot open source as well and contribute back where we can.
yeah, that's good. There is another question, and what are the results? I mean, we've been running Go Center for more than half a year now.
No, I think more.
Yeah, right. From January, it's like 9 months, and I think that it's about time to question ourselves and see if our architecture actually works. So, what is the uptime? How did it behave? What do we see after 8 months of production?
We were running basically 3 months before that, almost like even had in production clusters. So we designed a lot, and any big change we pretest a lot before production. So we don't want any downtime for production, and we never had. If you do the upgrade, we always get we have a notification about that. But so far, so good. And running on Kubernetes really helps us.
Yeah, so just as a proof, I will share my display here for a second.
Yep.
Here you go. I think you can see it now. I mean, there is no incident since it was up. We had a couple of scheduled maintenances, obviously.
Yeah, basically that's the new releases. Basically, that means a new release. Every time you release,
But they are actually zero downtime, right? So the fact that we put it on our status page doesn't mean that the service is going down.
Yeah, that's not going down. Basically, when we have these, basically we roll out the UI change. But if there is no UI change, which has no downtime, we do releases much more often when you see on that list.
Yeah, and just to, I guess my point is, thank you Kubernetes for allowing us to provide a service which has zero downtime for 8 months of production service. I think that's remarkable, and a lot of the credit goes to Kubernetes. Here's another question: how do you measure appropriate resource limits for your applications?
You basically have to run load tests. Basically, when you start the application first, you see how much it takes CPU and RAM. You could add about 10% on top of it. So basically, that's the request. And after, you apply load testing and see what is the max of CPU RAM is used per your application. You add a bit on top of it. That's a limit. Adding all these things, you have to test again and see how they behave. Basically, it's testing and testing and testing. It's not like just pure maths. You have to do adjust and adjust and adjust. Experiments and experiments. And of course, we do that before. Do on dev, we do on test, do that on staging, and we repeat. When we're happy, we only then we apply to production. Because production is production. It has to be no downtime. So far, so good for that.
Yep. Knock on wood. I think that's all the time we have. So Rimas, thank you very much for sharing that with us. And the webinar recording and slides will be online later today. And we're looking forward to seeing a future CNCF webinar. Have a great day. Thank you, and bye-bye.
Thank you.